Buon pomeriggio, graditi ospiti, signore e signori, e benvenuti alla nostra prima presentazione ufficiale nella piattaforma di Remtech Expo 2020. Sono Chiara Pozzuoli, Regional Manager Europa e responsabile dell'ufficio italiano di RWDI, e sono lieta di essere qui con voi a presentare un tema che per noi è un tema molto importante. Next slide, please. Il tema di cui parleremo oggi è cambiamento climatico e resilienza dell'ambiente costruito, e lo faremo coinvolgendo i nostri principali esperti dal nostro headquarter canadese. Next slide, please. Per chi di voi non ci conosce già, RWDI è una società di consulenza internazionale con headquarter vicino a Toronto, in Canada, che si occupa di ingegneria aerodinamica, ambientale e di analisi climatica, offrendo un servizio di consulenza in un vasto campo di settori. In questa slide vedete i nostri 26 uffici nel mondo, di cui Milano rappresenta uno dei più giovani. Next slide, please. Next. Questo ufficio è stato inaugurato nel 2019, l'anno scorso, a giugno, e ho il piacere di presentarvelo in queste immagini. Ci siamo occupati di una scelta accurata di questo ufficio e siamo in una prestigiosa sede storica che è la Fonderia Napoleonica Eugenia in zona Isola Milano, che vi invitiamo a venire a visitare non appena sarà possibile per voi. In Italia, nonostante la nostra giovane età, abbiamo potuto già vantare alcune esperienze significative, tra cui alcuni edifici alti, e in questa slide ne vedete alcuni dei rappresentativi, tra cui la Torre Unicredit e Porta Nuova Gioia in via Melchiorre Gioia 22, per entrambi dei quali abbiamo svolto delle prove sperimentali in Galleria del Vento per il sistema strutturale e per le facciate. Next, please. Il team multidisciplinare di RWDI è noto per la peculiare capacità di suggerire soluzioni integrate ed innovative alle complesse sfide del mondo costruito, analizzato in modo olistico. In questa pie chart potete vedere i temi di cui ci occupiamo, tra cui ad esempio acustica, vibrazioni, ma anche building physics e carichi eolici. Oggi ci andiamo ad occupare di un tema molto specialistico, che è il cambiamento climatico e la resilienza, e lo facciamo coinvolgendo il nostro vicepresidente per il settore buildings, Mike Williams. Please, Mike, next slide. Mike, I will hand it over to you from now on, and welcome to the platform. It's all yours. Thank you.
Wonderful. Thank you very much for the introduction. It's a pleasure to meet you all today. Today we're going to be talking about climate change, which is absolutely one of the world's biggest problems. And when we think about buildings, infrastructure, and industry, it's definitely one of the biggest risks posed to those world sectors. Well, we definitely need to continue efforts to reduce global greenhouse gas emissions through carbon reduction and alternative energy projects. The reality is that the climate has changed, and we need to begin to deal with those consequences today. As a result of this changed climate, we need to rethink industrial processes. We need to rethink the way that buildings are designed. We may need to rethink the way that we're operating buildings to ensure that they're resilient to both new climate normals and extreme weather events that, again, we are seeing today. Very excited for today's presentation, where we will be sharing some of RWDI's experience supporting the development of resiliency strategies at 3 very different scales. Mike Gibbons, a technical director within RWDI's climate and weather practice area, will be sharing his experience at a regional scale, supporting Saudi Arabia with the creation of new weather maps for the entire country. Joel Good, a technical director within RWDI's sustainability practice, will share recent experience developing a resiliency strategy for 150 of the City of Toronto's most important building assets. Lastly, we have Matt Edson, who's a senior project manager within RWDI's industrial practice, and he'll be sharing insights gained through a project where he led the development of a resiliency strategy for a specific piece of critical infrastructure. We have allowed time for formal questions at the end of the session, and so if you can hold your questions until then, that would be wonderful. I think the best way to submit them is through the chat window. However, if you would like to share them in Italian, that's more than fine. Chiara can act as a translator for us in that regard. So with the formal introductions complete, I'm going to hand the presentation over to Mike, and he will kick off the first technical piece of the session. Thanks again for having us.
Thanks, Mike. And as you mentioned, today I'm going to be talking about our use of climate modeling to define climate risk. Next slide. So when we consider climate, one way of looking at it is in terms of a length scale. We can look at how climate varies from a regional or country scale all the way down to an occupant scale. So for example, we can look at the country of Italy, and we can say pretty definitively that it's generally warmer than another country of Canada, where I'm currently located. So using various tools, we can drill down in our view of climate from that sort of broader country scale down to a provincial or diurnal scale, a city scale, a neighborhood scale, all the way down to a single occupant scale to understand how climate varies across these different lengths. Next slide. We can also think of climate in terms of a time scale. So this includes looking into our past, so using our past climate data to gain an understanding of our current climate. We can also look forward a couple days, weeks, or months to gain a better understanding of what our expectations of weather is going to be in that time span. And then finally, we can look into decades into the future to understand how our climate is going to change and how our climate is going to look in 2050 or 2100. Next slide. So one tool that allows us to look at climate across these length and time scales is mesoscale modeling. Mesoscale modeling is a computational tool that allows us to solve the fundamental equations of atmospheric dynamics on a gridded domain. At RWDI, we tend to use the Weather Research and Forecast model, or WRF model, which allows us to predict things like wind speed, temperatures, pressures on a gridded domain down to a scale of 500 meters or 1 kilometer, so that we can gain a better understanding of how climate varies across the different length scales and time scales that we're interested in. Next slide. So one project, and the project that I'm going to be talking about today that we've applied this to, is work that we've completed in the Arabian Peninsula. So in this case, we used both surface data sets as well as a mesoscale model using the WRF model to determine design wind speeds and climate zones across the Arabian Peninsula. Next slide. So, why did we use WRF? Why did we need to use a mesoscale model? In this case, the main reason was data availability. So, conventionally, most building codes and standards across the world up to this point have tended to use data available from airports and weather stations that are located across the country. Our experiences in Canada are generally, you know, based on this, United States and Italy as well. Most countries around the world have a sufficient data set that allows them to define what the climate hazards are across the country based on those point measurements at different stations, at least for populated areas. However, when we looked at sort of what the situation was across the Arabian Peninsula in terms of data availability at those conventional surface weather stations, what we found was that there were some locations, particularly in sort of the southeast portion of Saudi Arabia, into Yemen as well, that there just simply wasn't enough data available for us to appropriately define what the climate hazard was. So we knew going into this project that we would need to look at other data sources and very likely a mesoscale model data set that we created for this project in order to sufficiently define what the climate hazard was across the study area. Next slide. So this gives a pretty quick snapshot of, again, why we wanted to use our WRF data set. So this is showing a map of the Dubai area. And the green triangles are the surface stations that are available to us that had a sufficient period of record and completeness that would have allowed us to do a statistical analysis to determine a climate zone or a design wind speed. However, we can see that even though there's 3 stations available, when we look at the available data that we have out of the WRF model data set that we came up with, the density of data is actually a couple orders of magnitudes greater, and really allows us to define the climate variability across the city even, in terms of how we expect our design speeds and our climate zones to vary across that city scale and even neighborhood scale. So the resolution, the grid resolution that we're showing for the WRF model there is a 4-kilometer grid resolution, which means that we have essentially a virtual weather station every 4 kilometers in the east-west direction and north-south direction. So we've got a really dense grid of data available to us to perform our statistical analyses on, so that we can determine what the correct design parameters are. The other thing that we have coming out of this WRF data set is a sense of how the climate varies with height above sea level, or height above ground elevation. So not only do we have a conventional surface weather data set, we also have data sets going up to 2 kilometers above the ground, which for this particular project wasn't something that we needed. But when we're looking at how climate varies for high-rise buildings, long-span bridges, that sort of thing, this can be very important, because the directionality of wind or the temperatures that are going to be seen in tall buildings at 500, 600, 700 meters above the surface of the earth can be significantly different than what we're seeing at surface stations. Next slide. So Mike, if you can just press play on this wind event. This is just to show kind of a quick video that shows some of the types of weather patterns that we can see within the WRF model. So I think it's just starting to play now. So what we actually can get out of the WRF model is a time step of our sort of a single event. So this is just showing kind of typical weather patterns that we see within the Arabian Peninsula. So as the event progresses, you can see how the wind vectors are changing, and then you can also see how the temperatures are slowly increasing and decreasing as we go through the day. So you can see the colder temperatures are coming in from the north, and then as the day progresses, you get your warmer temperatures kind of moving up from the south and going northward. So this is just again just an example of the sort of density of information that we're able to get out of this WRF model when we run it in a hindcast mode, as we did in this case. Next slide. So what we did in this project was perform 30 years of WRF modeling. So we created a 30-year hourly data set across our study region. And again, as we introduced, the idea here was to design wind speed maps and climate zone maps. So once we had that data set, it was important for us to do a statistical evaluation and validation against the sort of dozen or so high quality climate stations that we had in the region. So one way we can look at this is, again, on that temporal scale. So how well the WRF model can sort of correlate against a high wind event that we've seen within the historical data from the surface weather stations. So this is an example of that kind of an analysis. And then Mike, if you go to the next slide. We can also look at it in terms of a more of a statistical analysis. So in this case, we're maybe a little bit less interested in making sure the peaks of wind events occur at the same time, and really more interested in making sure that the WRF model is representing the statistics of the the extreme wind statistics and the climate zone statistics that we are seeing from the surface weather station. So we're able to do a sort of apples to apples comparison from the historical wind speeds, which are the wind speeds from the surface weather stations, and the simulated wind speeds, which are the wind speeds that we're getting out of the WRF model. So what we found, again, in the high quality stations that we have in the area, was actually a really good agreement from the historical data sets to the simulated data sets. Next slide. So once we were satisfied with the performance of the WRF model, it was time to do some more statistical analysis, and then finally do contouring of the results, because that was really the intended outcome of the project, was to provide contour design wind speeds and climate zone maps across the Arabian Peninsula. So this is just a snapshot of the analysis that we have. So this is showing the 50-year return period wind speeds on the left, and the 700 return period wind speeds on the right. These are wind speeds in meters per second, 3-second gust speeds. The intent of this analysis was to feed into both the building code within Saudi Arabia, which is based on the ASC 710 design standard, as well as a unified building code for the entire Arabian Peninsula, which is going to be based on the IBC 2015, so the International Building Code 2015, and the IECC 2015, so the International Energy Conservation Code 2015. Next slide, Mike. And then this is showing the climate zone map, again, for the study area. So again, we can see that although the climate in the Arabian Peninsula, we're expecting to see fairly hot and dry climate, and that is indeed what we see across the study area. Although we do note some areas where we're getting into different climate zones, and a lot of that is really to do with elevation. So we can see that in the sort of mountainous regions of Yemen and Saudi Arabia, we actually get into kind of zones 3 and 4. So this is gonna work into the way that buildings are designed in these regions. Next slide. So this is, again, is just kind of a summary of sort of the data that we had available to us, the data that were created, and then an example of the output that we're able to produce from that. So at this point, the analysis that we've completed has actually worked its way already into the most recent Saudi building code. So if you look up the Saudi building code, you can actually see the design wind speed maps that we've created in there. We also provided support on a sort of a GIS basis for the seismic maps. So the seismic maps are going to have the same kind of look and feel because we also produced them. And the sort of unified building code for the entire Arabian Peninsula, the work there is still sort of underway. There's a lot of coordination between the different countries that are contributing to it. So there isn't yet a published unified map for the entire Arabian Peninsula in a code or standard yet, but as I say, that work is still ongoing. So that pretty much concludes it for me. I'll turn it back over to Mike, and he can introduce the next speaker.
Excellent. Thanks very much, Mike. That was very insightful. So we'll hand it over to Joel. As said off the top, Joel is a principal at RWDI and a leader in our sustainability practice area, and I'll leave it to Joel to talk about assessing the resiliency of buildings at a portfolio scale.
Great. Thanks, Mike, and Mike as well. Yeah, so I'm going to now take us from the high level kind of climate side of it to looking at how we actually apply some of the future climate modeling to discuss resiliency at a building level for a portfolio scale. Okay, next slide, Mike. For any climate change resiliency assessment, there's a wide range of study that can be explored. The future climate reviews can range from a light touch of just reviewing existing literature and future forecasting to a deep dive by performing regional and local climate modeling specific to that site, something like what Mike was showing you a minute ago. As well, the review of the built assets we're talking about also can range from considering simply an address, so a latitude and a longitude more or less, and the asset type, to maybe a full-on site conditions audit where you go in and look at the conditions of an existing building physically. To give an idea of a strategy for a large portfolio of buildings, I'm going to talk a little bit about this case study that we worked on recently with the City of Toronto in Canada. Next slide, please, Mike. So not unlike most major cities around the world, Toronto has felt the impact of an increase in frequency and severity of extreme weather events in recent years as brought on by a changing climate. The event shown here was a torrential rain event with over 70 millimeters of rain recorded in 2 hours, leading to obviously some catastrophic flooding around the city. The increase in frequency of events like this has spurred the City of Toronto to review their assets to assess the resiliency to a changing climate, how quickly, how susceptible they are to damage from events like this, and how quickly can they get bounced back to business as usual following an event like this. Thank you, Mike. Next slide. So as the city has many building assets, an approach was needed to perform a high-level portfolio assessment. So that would be flexible to a varied building stock. It would be able to assign quantifiable risk levels so that we could actually compare and prioritize. those action items to build a plan towards a resilient infrastructure for the city. So the feedback needed to be concise and actionable so that the city could prioritize and act on these. Next, Mike. And I think, Mike, if you could just step through the next 4 or 5, you'll just see an example here of the final output of what the report looked like. So it was a very short 4 or 5 page summary for each building that had information on the site itself, and then a series of recommendations that could be implemented on site by the asset managers, the City of Toronto, or the local on-site staff that are dealing with the building every day. Okay, next slide. So a process was developed that would investigate the state of the existing building. It would assess the climate hazards that are specific to that site, and then map the potential vulnerabilities of the asset. So we're taking that climate data and then mapping it back to the building, asset by asset throughout the building. And we then quantify a level of risk for each of those combinations. So based on the severity of that risk and the likelihood of that risk happening, or that event happening. So this was by no means a linear process, as improvements to the asset stock would be ongoing based on priorities. So it was the process followed guidance from several sources, including the ISO 31000 standard for risk management, as well as a Canadian standard, the PIEVC, Public Infrastructure Engineers Vulnerability Committee, engineering protocol for climate risk assessment. So we followed those steps. But as you can see in the diagram, it was by no means a linear process. We would look at the building, assess the hazards, and look at the vulnerabilities associated with those hazards and start to quantify risk. And then once that was complete, that's a circuit that continues. So you're never going to be 100% risk-free to climate vulnerability. And the idea is that we're constantly revisiting and advancing the buildings as they move forward in their lifespan. Okay, next slide, Mike. So the first step was reviewing the building assets, like I mentioned. And the city had us consider over 150 properties, ranging in scale and complexity from historic buildings housing provincial offices, like you see here, to small park infrastructure along a pathway, like you see on the right-hand side of the screen, and everything in between. So 150 buildings ranging in scale and size and use. Which is what the assessment needed to consider. So we performed a site visit to each of these buildings to determine the current state of the HVAC, the envelope, the operations, as well as other resiliency data. So for each of the sites, we would then determine the local climate hazards. As Mike showed earlier, there's different ways of gaining that information. For us, we were fortunate that the city had also commissioned a climate modeling project a few years before, as you see here. So a lot of that data was available to us. When doing these studies, that's often part of the challenge, is determining where the data comes from that you can rely on for these future forecasts. The forecasted data included temperature, precipitation, wind, storm events, snowfall, freeze-thaw cycles, among others. And the further site-specific context was layered in using additional contour and flood mapping that we did. Based on the list of the climate hazards, a set of building vulnerabilities were then determined. So this database ranged from mechanical system vulnerabilities, such as undersized cooling equipment, to safety and emergency vulnerabilities, such as backup generators in potentially flood-prone properties, or sorry, flood-prone areas of the building. And you can see a list of the vulnerabilities was developed. Next slide, Mike. So then, there we go. A risk score was then developed for each asset and vulnerability based on the likelihood of the event occurring, and then the severity of that. So you can see the scale of probability and severity. And in such, a resiliency score was established for each of these vulnerabilities, amassing into a resiliency score or report card for each building. So next slide. So with over 150 buildings, I'll just wait for this to. Next slide, Mike, are we waiting? There we go. So with over 150 buildings, the 5 climate change threats and 30 systems or assets and vulnerabilities located for each site, you can tell that this list quickly, the list of potential vulnerabilities quickly multiplies here. So you can see that there's great value in creating a prioritization of these so that we can pull out the most important risks associated with the buildings. Next slide. So a resiliency score was established for each vulnerability. And this quantification of risk allowed the city to prioritize the capital that they were going to allocate to the mitigation efforts. So you can see here are top 3 recommendations that were common across all the assets. So there was a variety of recommendations, but the top 3 that we saw come up quite frequently were that we wanted to create or review extreme weather operational plans and procedures. So it was quite clear that there weren't plans in place to deal with future climate risks. Also in the City of Toronto, there are opportunities to connect to a district energy system. So there was a recommendation to do that, to increase the redundancy of energy and power supplies. And also to relocate backup power to above the floodplain. So this was a very common risk too, was that the backup power scenario was in a very flood prone location, which really is a hindrance to many of the hazards that happen in Toronto are flood related. So definitely something to consider. So these were some of the top recommendations, but as I mentioned, that as these get addressed, that process can be revisited, and we can go back to the beginning and start to look at the next set of the next layer, I guess, of risk as far as what the vulnerabilities are. Next slide. So some of the lessons learned we had along the way on this project were make historic and forecast climate data a public good available in a standardized format. So as I mentioned, we were quite fortunate that the City of Toronto, and to know it was no surprise, but the City of Toronto had a good set of localized forecasted data available. So we could take that data and apply it to this data set of buildings. For many sites where we've worked, that isn't so clear. And so you end up having to do a lot of research to figure out which is the most applicable future climate data to be using as far as precipitation and flood, temperature. And so having that data available to an urban environment is very valuable for allowing the buildings of that site or that city to be analyzed. So number 2 was that developing a standardized assessment methodology for the city would be a great benefit to the public and private sector alike. So that process that we followed, which was coupled together from a series of other endeavors, was one in which we were happy to share as we're doing now. But that sort of a standardized assessment needs to be considered so that these sorts of assets across different portfolios can start to be considered. And I think with the last slide, I think that summarizes. So I'll hand it back to you, Mike, and we can continue on.
That's great. Thanks very much, Joel. There's a little bit of lag in the slide change there, so thanks to the audience for your patience. But onto the presentation from Matt. So Matt's going to be speaking about resiliency at the scale of a single project, and I think that this will continue this sort of down in level of resolution in terms of how we can look at the resiliency of physical assets to changing climate parameters. So with that, I'll hand the presentation over to Matt.
Yeah, thanks, Mike. So as Mike kind of mentioned, well, the last 2 talks discussed some interesting wide-scale approaches to climate analysis and broader regional assessments. I'm going to bring the resolution down to a project level application, which is going to utilize or can utilize a lot of the concepts and tools previously discussed. So on the next slide, sharing a bit of my backyard here in Alberta's foothills from a view atop Mount Yamnuska. We'll start from a high level discussing the who, what, and where, and why, some of the concepts of resilience, and finish by walking you through a bit of a project example. So on the next slide, if we're moving forward, sorry, I'm just going to wait for that. Yeah, so words like resilience can bring a lot of different frames of reference to different people's minds, but broadly speaking, resilience is essentially the ability to kind of spring back into shape when facing kind of a challenge. So incorporating resilience really supports attainment of sustainability, which is kind of another key buzzword lately, through hazard mitigation, to kind of reduce loss, as well as, adoption of climate adaptation measures to both minimize actual or expected climate risks, and perhaps most importantly, especially for businesses, is to maximize the ability to exploit beneficial opportunities that are coming out of here. So, a key takeaway is that resilient operations are able to avoid key disruptions to business and keep operating. So moving on to the next slide, I feel this message is nearly universal across businesses and sectors, including the public sector, and consists of disruptions across an operations value chain. So it's really important to kind of assess how an asset or how a structure or building is impacted across that value chain. For example, drought could prevent a mine site from operating, which may result in millions of lost revenue per day, or flooding in a key supplier area may actually truncate your supply chain, perhaps eliminating that key supplier altogether, or the ability of supplies and personnel to reach your site, negatively impacting your short and long-term cash flows. Conversely, of course, according to the Global Commission on Adaptation, investing in resilience could yield about a 4-fold return on investment, which is massive. Like, that's a pretty good return. So if we're moving on to the next slide, obviously that's as good as reason as any why we should address it or assess it. Good resilience planning obviously identifies vulnerabilities to prevent those disruptions, but another major example of resilience is the potential to save lives. If you're incorporating resilience planning into your asset, into your structure, you have potentially the ability to save lives when faced with a major event, such as a forest fire or a flood. Another concept, of course, that's increasingly important for companies as well as municipalities is the concept of ESG. Connecting high-level ESG ambitions with project-level impacts can help improve the social license to operate by ensuring local stakeholders aren't burdened by upset due to lack of diligence. If you've got a flood on your site and the impact is kind of trickling down into the communities that you live and work, that can be a negative view for your organization, for the town in general. So this in turn can support improved profits by actually increasing or attracting investors to your company or to your group as a stable long-term investment, help gaining access to financing, potentially improving loan conditions, in addition to other non-financial capital such as constructed capital, natural capital, improving the usage of assets and around your site, as well as human resources capital with people wanting to work for firms and for organizations that kind of utilize some of these concepts and incorporate them into their projects as well. So on the next slide, assessment of resilience, much like climate, is a very dynamic process. As Joel kind of alluded to, it kind of necessitates continuous reevaluation. While it may be crucial in the initial stages to assess resilience in the planning phase and improve the long-term project feasibility, it's also critical to kind of continuously verify these measures against changing conditions, such as surrounding land use. Further assessing resilience throughout an asset's life cycle helps identify and take advantage of critical opportunities, such as the ability to redefine an asset in the future, which may be past its design use. On the next slide, we're going to walk through a little bit of a project that kind of highlights this. And this was a spillway plan for an irrigation district in southern Alberta served by a canal system. The irrigation district here supports hundreds of thousands of acres of valuable farmland, as well as provides drinking water to nearby communities, generating millions of dollars in net profit per year. This project was initiated to protect those services, the spillway itself, and required an assessment of the project's climate resilience as part of its external funding requirements through a federal grant program here in Canada, known as the Disaster Mitigation and Adaptation Fund. On the next slide, Over the past decade, the canal system has been unable to manage excess water in response to increasing water inputs in both mean annual precipitation and short-term extremes from rainfall events and spring thaw. Here in Canada, we have a considerable amount of snow, and in the spring, when it thaws, it results in a significant amount of water being added, water inputs being added into hydrological systems. Further kind of changes in land use in the area and drought has reduced the natural capacity of the area to manage these inputs and increased the area's vulnerability to short-term extremes, resulting in multiple flooding events over the past decade or so, disrupting valuable service delivery such as the agriculture industry, which has necessitated the spillway project as a mitigation measure. So on the next slide, in assessing the project, we critically evaluated asset vulnerability, including the effect of continued deterioration of the area's natural resilience, such as wetland destruction from drought over the asset's intended 100-year life. And to complete an accurate assessment, as Joel kind of alluded to a little bit earlier, a suitable protocol is necessary. On this project, we utilized the Canadian developed PIVC, which is used in other countries as well internationally as a framework for completing these types of assessment, and broadly includes kind of project definition, data gathering, risk assessment, engineering analysis, and recommendations for adaptation. And as Mike kind of alluded to and discussed a little bit earlier, Mike Gibbons, it's important to have reliable and local weather data to identify site-specific risks. Localized impacts can differ considerably compared with large-scale regional means. And here we were able to pull some resources from agencies such as the Canadian Water Office and Canada's Climate Atlas, as seen on these charts. But if data is unavailable, it's important to utilize appropriate tools to gain it, such as those described by Mike Gibbons and Joel Good a little bit earlier, to generate them. So this localized data that we were able to access helped us kind of identify some site-specific vulnerabilities and risks. As I mentioned a little bit earlier, this includes damage to the local wetlands due to drought conditions. I've seen the minimum daily flows over the past several years on the left. This region can have actually almost no flow when there's a drought event. There can be very, very limited water going through the St. Mary's River, which is what we're seeing there. Conversely, we can see massive spikes or extreme levels of precipitation and flow, as seen on the blue line in that chart as well, demonstrating kind of the maximum, reaching almost 900 cubic meters of water, which is a considerable amount of water considering that the extreme low is nearly zero. And on the right-hand side, we can kind of get an idea of thermal stress from increasing temperatures, as well as the extremes that can impact, such as drought events, which are going to be much more prevalent in the future, as we can tell. So on the next slide, running through a little bit more of that process, after we identify these key vulnerabilities, we were able to utilize risk assessment tools to evaluate and rank the impacts of risks to the project, such as a risk matrix and registry to prioritize adaptation measures. This helped, in fact, identify drought, of course, as a key climate risk and a root cause of related flooding risks related to kind of the natural infrastructure deteriorating. So persistent drought events commonly are occurring with a greater frequency, negatively impacting wetlands in the surrounding area, negatively or deteriorating the ability for water retention, water filtration, also negatively affecting wildlife habitat protection and erosion and sediment control. So faced with extreme precipitation events, it reduces the ability to deliver services by the spillway, or potentially reduces the ability to deliver services by the spillway with a proposed spillway project, and expose local infrastructure such as roads and rail to damage. So in the next slide, as kind of a final stage of the assessment, we recommended that water be maintained in that spillway to supply and maintain the local wetlands, which we previously identified as kind of a critical point. The cost of that was relatively negligible. We also recommended planting drought-resistant crops or plants in the wetland to improve the resilience of that natural infrastructure. In addition, we recommended including ongoing maintenance in the stormwater management plan to maintain the wetland and mitigate those drought impacts to help maintain areas' natural capacity and improve the ability of the spillway to manage future water inputs in response to high precipitation events such as spring thaw or rain events. So overall, the construction, if we're looking at the kind of conclusion of this project, so on the next slide, overall the construction of the spillway was estimated to cost roughly $50 million, which is a reasonable sized price tag for a project. But the delivery on that project was about $20 million in net economic benefits. kind of return on that investment if service delivery was maintained. But to put that in the context of recommending, an adaptation cost of about $35,000 per year, that's pretty small. So you're gaining $20 million in benefit for a small $35,000 per year investment. So it helps ensure that this project is a long-lasting benefit to the region, and that a $20 million net benefit is in fact realized through continued operation of the spillway and maintaining of services. And that brings my my presentation to a close, and I think we're going to open the floor to discussions. Thanks again for listening.
Grazie a tutti gli speaker di questo intervento. Se volete possiamo ripassare all'italiano, io sono qui per voi, se avete domande sentitevi liberi di mandarle direttamente a me oppure di scriverle nella chat box. E invece se volete continuare con noi la discussione siamo ancora disponibili per qualche minuto perché la sessione si chiuderà tra 15 minuti. Mike, would you like to just have a closing speech from your side?
Yeah, well, I think we can give it a minute or two and see if any questions come in. While we wait, I really enjoyed the presentations from our speakers, so thanks on my behalf. And I think seeing the thought of resiliency at those different scales was excellent and really allows you to start to connect some dots. As I was watching, I had some questions, so I think maybe to get the question and answer started, I'll pose a couple questions of our speakers, and perhaps those inspire some questions of others. Mike Gibbons, off the top, you were speaking about using simulations to predict both historic and future climate scenarios, and you gave some examples of how you could validate historic climate predictions by comparing it to existing record sets. I'm wondering about future climate predictions and how you have a level of confidence over the accuracy of those future predictions.
Sure, thanks, Mike. Yeah, I mean, what the question really comes down to how we look at uncertainty. So we can classify uncertainty into kind of two general buckets. You've got model uncertainty, so how well the underlying model is actually replicating the physical processes that we're trying to investigate. And then you also have like a statistical uncertainty, which is really most akin to sort of random chance or something like that. So we have a pretty good understanding of how well our models replicate the physical processes. So that's probably the lower bit of uncertainty related to future climate projections. We know that if we go to a fine enough resolution and that we've got sufficient boundary conditions defined, we can trust that the model is going to give us something sensible. The bit that we don't have a clear understanding of right now is more related to the random chance, and part of that is related to the pathway uncertainty. So we typically, when we look at different climate change scenarios, looking forward into the end of this decade, we're really looking at different remote RCP scenarios and the corresponding changes in global temperature that are associated with those. And we're still not certain, which pathway we're on at this point. So in terms of the future climate projections, what the climate is going to look like in 2050 and 2100, for example, the pathway that our global CO2 emissions ends up taking will have a really big implication on where our endpoint is in say 2050 or 2100. So that's why whenever you're looking at future climate projections, it's important to look at a good cross-section of those future climate scenarios and have a good understanding of what your worst case is. You know, temperatures, it's generally more CO2 is going to lead to higher temperatures. We don't necessarily want to say that the highest RCP pathway, which is 8.5, we don't necessarily want to say that that's going to definitely lead to more precipitation in your area, for example. That could also be, you know, perhaps not the worst case from something like a snowfall perspective or something like that. So it's best practice to be considering a variety of different RCP pathways, and then also considering the historical climate as well, and sort of take a path of least regrets in terms of defining that future climate risk.
Yeah, that's great, Mike. Thanks very much. Yeah, I think the future is inherently uncertain, and I think that there's a range of scenarios that need to be considered, but it's fascinating that there's tools that allow us to provide some quantification of what those future scenarios could look like. So we received a question through one of the participants asking about experience looking at sea level rise and sea level water surge as a climate change threat. I guess I'm wondering, Mike, would you be able to share any of our experience in that regard?
Yeah, so I know in terms of a location, Miami, Florida and Miami Beach is one location that is starting to, you know, seriously look at sea level rise, especially for buildings that are sort of being built. So new building construction, making sure that the lower floors are, you know, not critical infrastructure, so more parking, and that there aren't any, you know, power generation or anything like that, any emergency power generation below grade. Because they're accepting that they're going to, you know, they already see some flooding events, and they're expecting to see more flooding events as they move into the future. It's definitely something that we're seeing more and more in terms of risk assessments and resiliency assessments in terms of you know, RFPs and that sort of thing that we're responding to, that the topic of sea level rise is certainly coming up. And it really depends on the individual location that we're talking about, you know, as to what the best approach is in order to try to mitigate against that hazard.
Yeah, fair answer, Mike. Yeah, I can recall a project I was recently involved with in Hong Kong, and doing some background research on work that had been done, and both active efforts that have been undertaken to start to mitigate the challenges of sea level rise, but then also doing some research and looking into what the planned activities were. And so I think we're always in this state of activities that have happened, and then also having to be cognizant of what's already in the pipeline and mitigations that are planned.
Mm-hmm.
I think another good example of that, Mike, if I can jump in, is also the work that's been going on in New York City after Hurricane Sandy, too. The work around flood mitigation in Manhattan and the Rockaways. I think there's examples of the modeling side of it, but if you want to look into some implementation and real kind of strategies, that's a really good spot to look to if you look at the plans that have come out of there.
Yeah, great point, Joel. So I received a question through the chat window privately sent to me, but the question is about a lot of our examples centered around public infrastructure or public assets, and a question about, is the private sector taking this seriously, and are we seeing any interest from private developers or private clients? And Joel, I know you have some experience in that regard, and I was wondering if you could maybe tackle that answer.
Yeah, for sure. Yeah, it's a good question. We are seeing it on both sides right now, where it's I think the program that Matt was describing a little bit is an example of a government mandated process. So to gain infrastructure funds in Canada, for example, you need to do a climate lens study considering these sorts of efforts. So every public project going after that funding is required. So we are seeing more and more of those sorts of mandated efforts, which dictate the public to go into this kind of study. But we're also seeing people just coming to us who have a portfolio of buildings or one building, but who are just seeing, they want to really understand their exposure to risk. So like the rest of their financial risk exposure, this is just another layer of risk that they need to understand. And so a lot of folks that are coming to us don't really understand yet where this process is going to lead them. They don't know what the mitigation or what kind of implementation they're going to do, but they want to understand how exposed they are and what that means. And so we're seeing a lot more kind of, typically it's groups of buildings that so people that own portfolios, and they're noticing rising insurance costs as a result of flooding or that sort of thing, and they want to know what their future exposure is. So I would say that probably driven by either the mandated studies or this new exposure and higher insurance costs as a means to really drive that public sector, and we're starting to see that now.
Just to add a bit to what Joel was saying. Was yeah, absolutely. So I think corporations are starting to connect those high level ESG conversations and bring that kind of down into an operational phase. So we've had quite a few conversations, or I have at least, with oil and gas organizations here in Alberta, and that they're starting to. They've been a big push here. Obviously, there's a lot of public pressure on them, so they're kind of seeing that as an important aspect of their future business operation to incorporate some of this, as well as in the mining sector as well. Here in Canada, we've seen a huge push. And it's starting to kind of kick off a little bit with implementing some of these resilience strategies for their assets. Yeah, for sure.
That's great. We have one more question. Well, there's several more questions, but I'll summarize this one quickly. And Matt, I'm going to pass it to you, but if you could answer quickly, we only have 4 minutes left. There's a question about what's the key driver for giving consideration to resiliency, and I think you just alluded to it in your response there, but maybe just to bring it home, you talked about a lot of different potential drivers as to why one would give consideration to resiliency. Could you pick one, and what are we seeing as the biggest reason why people are coming to us for these types of studies or challenges?
Yeah, really quickly, I'll talk fast. The big driver is money, at least in an industry side of things, which is where I'm kind of a project manager. So, money is really key. And without the ability, the social license to operate, with banks coming forward and putting financial pressure in terms of loan terms. So, organizations are finding that, if they meet certain resilience milestones, they'll actually have reduced interest rates for their loans. As well as financing. In our first quarter of 2020 here in COVID, resilient companies or sustainable companies outperformed their counterparts. 94%, I think, is what came out of that. So a big push is finance, and recognizing that in order to be operating in the future, they need to have these kinds of assessments incorporated.
That makes a lot of sense. Thanks a lot, Matt. Well, that brings to a close our presentation and our session. Thank you all so much for attending. Really appreciated the thoughtful questions, and we look forward to meeting many of you and engaging with you as REMTech continues. Chiara, do you want to provide any closing thoughts?
Grazie a tutti per aver partecipato, è stato un piacere avervi qui e siamo nella nostra room in caso di domande e suggerimenti e vi aspettiamo. Grazie.
Thank you.
Thank you.
Yeah, thank you.
Thanks, everyone.